Jamb 2026 candidates, welcome to the continuation of our chemistry lecture. As you know, we are destroying Jamb syllabus, okay? We are continuing today with acid. But before we continue, get your pen and your notebook to jot down whatever you understand in this lecture because you are definitely going to need it for subsequent revision. Now, let's concentrate, settle down. Our topic here is acids. Acids. What comes to your mind when you hear of the concept acid? When you hear acid, the first thing to enter your mind should be hydrogen ion. Proton. That should be the first thing that comes to your mind. Ionization. Hydrogen ion. Proton. Ionization. Anytime you hear acid, these are the features that should come in mind. Anytime acid is heard, anytime you see acid, just think of, ionization, hydrogen ion, proton, acidity, acid. Now let's look at the definition we have here. An acid is a substance, or acid are substances whose aqueous solution furnishes what? Hydroozonium ions, which is also known as what? Proton donor. Acid are called what? Proton donor. That's acid. What is the meaning of aqueous solution? Aqueous solution means a solution, or when a solute is dissolved in water. That's aqueous solution. Aqueous, this aqueous here is for water, aqua. It is derived from aqua, okay? Aqueous solution, but I like calling it aqueous solution, okay? Aqueous solution, that's solution with water. There's water inside. The solvent is water, okay? So acids are proton donor. The textbook definition of acid, I place this definition here because I want you to understand what an acid is and understand all the features of an acid. In case if Jamb come from any direction, you go tell them, say you get plan A, you get plan B, you get plan C, you get plan D. That's it. So the word furnish here means form, create, to form. So aqueous solution form hydroozonium ion. So when acid dissolves in water, it forms hydroozonium ion due to ionization, okay? Hydroozonium what? Ion, which is what? 3 molecules of hydrogen and 1 molecule of oxygen. Hydroozonium ion, and hydroozonium ion is what? Is a proton. It's proton. So acids donate proton. They donate what? Proton. Now let's look at the old definition, the old textbook definition of acid. I will tell you that one, okay? You are going to see it in chemistry textbooks. This definition was by who? Arrhenius. Arrhenius defined acid like this, what you are seeing here on the screen, okay? On this definition of acid. But it's not like what you have in the textbook, oh. But let me define it. An acid, according to the textbook, an acid is a substance that donates hydrogen ion or proton as the only positive ion when dissolved in water. Don't be the same thing. I make that definition easier by giving you this. A substance whose aqueous solution. What is aqueous solution? When the substance is dissolved in water, it forms what? Hydroozonium ion. This is the ion it forms as the proton. This is proton, okay? Positively charged. Proton is positively what? Charged. That's the proton it donates when it ionizes in water. That's it. So let me ask you, what comes into your mind when you hear acid? Write all of them down inside your notes. I already taught you. Now let's look at the properties of acid. Remember, there are about 3 other, scientists or chemists who define acid in various ways. Okay. Laurie Brosted defined acid in his own way. Go and find them out. Okay. Search on them and know the way they define acid. Okay. Lewis defined acid in his own way too. Lewis also defined acid. So one other one left. So just look at the contributors of the acidic concept or the acidic theory. Okay. The contributors of acid theory. Look out for them and learn their definition. I think Brosted, Laurie was the one that defined acid as a substance that donates hydrogen ion. Now let's look at the properties of acids. The first property of acid we have here is it has a sour taste. This one is a physical property. It has a sour taste. Okay, it's usually sour taste of an acid. Okay, that's the characteristic feature. It turns blue litmus paper red. So when blue litmus paper is turned to red, that tells you that that solution is what? Acidic. This one is what? A physical property, turning blue litmus paper red. Now looking at the most common chemical properties of acid, the first there is what? It reacts with metal. Acid attacks metal, especially the strong acid. They attack metal to what? To produce what? Hydrogen gas. So when they attack metal, they form the salt of that metal, and also during the process, hydrogen gas is liberated as a what? Byproduct. An acid is a conductor. They are good conductors. Why are they good conductors? Because they ionize. Okay, they ionize in solution. They have free ions. That's why they are what? They are conductors. Okay, conductors of electricity. Now, what are the examples of acid? We have hydrochloric acid, a very strong acid. We have H2SO, for which is tetrazonophil 6 acid. We have triazonitrate 5 acid. All these are inorganic acid. This one I just mentioned, they are inorganic acid. Why? We also have organic acid, and the organic acid includes ethanol, citric acid, and tartaric acid. Citric acid is used to do what? They use it to mimic, all those fruit flavor, all those fruity flavor. Okay, like most of the time when you buy all those soft drink, they will tell you this one is orange flavor. It's not real orange, oh. It's not real orange. It's the flavor. Okay, it's not even extract. It is the flavor of that fruit that was manufactured in the lab. Okay, so it's not a real fruit. Oh. They use this citric acid to make those stuff, you know. And citric acid can also be used to preserve blood. Okay, citric acid is also used to preserve blood for blood donation. When they donate blood into pints, there's usually citric acid or citrate inside that pint of blood that helps preserve the blood. Okay, then tartaric acid is used in industries that produces what? Fruit juice. Okay, fruit juice. So take note of this. Jamb, they set question from all these things well. Okay, so ethanoic acid is found in what? Very common in what? Vinegar. Okay, very common in vinegar. It is also important to note that acids are divided into strong and what? Weak acid. Okay, acids are divided into what? Strong and weak acids. The strong acids ionize in water completely, or they ionize in a solution completely. But the weak acids either ionize partially or they ionize slightly. Okay, they either ionize partially or slightly. Strong acid is also corrosive, highly corrosive, because it's a strong acid. Weak acid is what? Poorly corrosive, sparingly corrosive. So that's that for acid. And one thing about strong acid is that the pH of the acid, okay, when you check the pH of a strong acid, you are going to see like the red is going to be very strong red. Okay, it's not going to be all those bleached red. No, the more acidic the solution becomes, or the stronger the acid, the thicker the red. Okay, the thicker the red. But the weaker the acid, the lighter the red. Okay, just the same thing as base. The more basic a solution is, the thicker the blue, thick blue. Then the less basic the solution is, the lighter the blue. All right. Now the uses of acids include they use in manufacturing fertilizers. Now the uses of acids include they are used in the manufacture of fertilizers. They are used in food preservation. They are used in cleaning agents. They are used in industrial processes. Like I told you that they use acid, like tartaric acid, to manufacture fruit juice. Citric acid is there, and lots more. Now let's look at bases. Bases. What is a base? Acid. Base is an opposite of acid. It has the opposite property of an acid. So if a substance is not acidic, it is more likely that that substance is what? Basic, as long as neutralization is concerned. Now let's look at the definition of basics. Okay, so bases are substances that furnishes hydroxide ion. So basic does what? It produces hydroxide ions. And how does it produce this hydroxide ion? When it's dissolved in aqueous solution or in water, okay, it forms this hydroxide ion, and this hydroxide ion, it accepts proton. Okay, so base is the substance that accepts that proton or hydrogen ion donated by acid. Okay, so base accepts it, okay, during neutralization reaction. So base does what? It accepts that proton. That's what base does. So base is a substance that furnishes or produces hydrogen ion in aqueous solution. That's a base. And the properties of base include it has a bitter taste. Okay, it has a bitter taste. It's slippery, has a slippery feel. Okay, it draw. It turns red litmus paper blue, just like I explained for acid. Base now is blue. Now the chemical properties of base, it neutralizes what? It neutralizes acid. Now let's understand the difference between a base and alkali. Both of them are different too. They are closely related, but there's a slight difference between two of them. Okay, so a base is a substance that furnishes, that's any substance that furnishes hydrogen ion in an aqueous solution. Is also a proton acceptor, positive ion acceptor, or hydrogen ion acceptor. That's that for base. Then alkali is a basic hydroxide which does what? Dissolves in water. Alkali is a basic hydroxide which can dissolve in water. A basic hydroxide. So alkalis are basics, but they can dissolve in water, because there are some other bases that can't dissolve in water. Basic hydroxide that dissolves in water is known as alkali. All right. Bases are not hydroxide. Okay, bases are not hydroxide, but alkalis are hydroxides. Bases only turns to hydroxide after dissolving in water, but alkali is already a hydroxide. Okay, it's already a hydroxide and is soluble in water. So when a base dissolves in water, it becomes an alkali. Hope you understood. When a base dissolves in water, it becomes an alkali. For example, potassium oxide is a base. It is not an alkali. But when it dissolves in water in an aqueous solution, it forms aqueous solution, it dissolves in water, it furnishes hydroxide. Can you see? It produces hydroxide ion. This hydroxide ion that it produces, it shows you that it has formed potassium hydroxide when dissolved in water. That makes it an alkali. That shows you that it has turned from base to alkali. So when you dissolve a base in water, alkali is formed. As simple as that. The examples of bases include potassium oxide, sodium oxide, calcium oxide. All those are bases. But examples of alkalis include sodium hydroxide, potassium hydroxide, and ammonium hydroxide. You can see that they all have hydroxide and they are all soluble in water. All these hydroxides you are seeing here, they are formed when the bases of these metal and this ammonia are dissolved in water. Okay, when you dissolve their bases in water, they furnish or produce hydroxide ion and become what? Alkalis. As easy as ABCD. Now the use of base is used in making soap. It's used in neutralization. That's neutralization reaction where acid reacts with base to form salt and water only. Base is used to make soap. Okay, remember the manufacture of soap where you react an ester with alkali. Okay, you react an ester with what? Alkali. Okay, so here it is called base because it is seen as base. You react, for example, you react caustic soda. This sodium hydroxide is called caustic soda. So you react caustic soda with ether to form what? Soap, and that's saponification for you. And during the process, propan 1,2,3 triol is formed alongside the soap formed. This is organic chemistry. We are going to get there soon. All right, industrial cleaning is also used for industrial cleaning, especially caustic soda. Sodium hydroxide is used for industrial cleaning, for bleaching. If you have been to a place where they make cotton wool before, cotton wool factory, okay, you can search it online and see how you make cotton wool. Normally, when you bring cotton is not usually that white. When you bring it, it's not usually that white. It's not usually that clean. It's brownish. Okay, you have to bleach it and bleach it. You use caustic soda in the process of bleaching, cotton and even fabric. So it's used as a cleaning agent industrially, and it's used in manufacture of paper. So if they ask you what's the industrial use of alkalis or bases, you can say what? In cleaning, in manufacture of paper. It can also be used in manufacture of salt industrially through neutralization reaction, and so on and so forth. Let's look at salt. There is a kind of reaction called neutralization reaction. Neutralization reaction is a kind of reaction where acid reacts with base to form salt and water only. Nothing else is formed in that reaction apart from salt and water. If any other compound forms alongside salt and water, just know that that reaction is not a neutralization reaction. If any compound forms alongside salt and water, just know that that reaction is not regarded as a what? A neutralization reaction. So neutralization is when acid reacts with base or reacts with alkali to form salt and water only. Neutralization reaction can also be defined as a chemical process whereby hydrogen ion combines with hydroxide ion to form what? A metallic ion. And that metallic ion formed is salt. Okay, salt. So acid reacts with base to form salt and water only. Now the definition of salt, according to what we have on the screen, is a compound formed when acid reacts with base or metal. Yes, this is the simplest definition of metal. It is, you don't only get salt when acid reacts with base. No. Remember the property, remember the most common chemical property of acid. Acid reacts with metal, especially metal higher up the activity series. Okay, acid reacts with those metal to liberate hydrogen gas and the salt of that metal. Okay, the salt of that metal is formed. Hydrogen gas is liberated as a byproduct. This is a method of forming hydrogen gas, a method of producing hydrogen gas. So you can see the simple definition we have here for salt. Okay, a compound formed where acid reacts with base or reacts with metal, just like I explained. But textbook also defined, salt in another way and in a more, in a more explicit way. And I'm going to teach you that. Most textbooks will tell you that salt is a substance formed when the replaceable hydrogen ion of an acid has been replaced by metallic ion. So during the formation of salt, what happens? There is pairing, replacement. Okay, hydrogen ion is donated by the acid. The metal donates its metallic ion. So the acid accepts what? The metallic ion and give out the hydrogen ion. So the hydrogen ion or the replaceable hydrogen ion continues to get replaced by metallic ion. When it's completed, salt is completely formed. As simple as that. So that's how salt is formed. There is an exchange of ion. Exchange of ion. Hydrogen ion is exchanged with what? Metallic ion. Remember, the replaceable hydrogen ion. That's what is transferred. That's what is exchanged to form what? Salt. Okay? And before we progress to the types of salts, there is one terminology I want you to know. One term that is very, very important in acid. I want you to know. Basicity of an acid. We are going to treat it, okay, later, but I want you to put that in mind. Basicity of an acid is the amount, when you say basicity is the amount of replaceable hydrogen ion possessed by an acid. When you say basicity of an acid, basicity is the amount of ion that this acid is willing to donate. Amount of hydrogen ion, amount of protons that this acid is willing to donate to exchange with what? Metallic ion to form salt. As simple as that, chicken. Easy peasy. Now, we are looking at the types of salt. The first type of salt we have here is normal salts. And normal salts are formed from complete neutralization. We have complete neutralization, we have what? Partial neutralization, and we have incomplete neutralization. The complete neutralization means that all the replaceable hydrogen ion of this, this acid were replaced by metallic ion. It was replaced completely by what? Metallic ion. Okay? And when it's replaced completely, the normal salt is formed. An example of normal salt includes sodium what? Chloride. And how is sodium chloride formed? When you react hydrochloric acid with what? Sodium hydroxide. Sodium chloride is formed. Now, What kind of acid and base gives you a normal salt? Or what kind of acid and alkali gives you complete neutralization? A strong acid and a strong base gives you complete neutralization because both of them are strong. When they come together, they give you complete neutralization. All of them eat up their hydrogen ion and their hydroxide ion. All the hydrogen ions are completely replaced by what? The hydroxide ion, because both of them are strong. Both the acid and the alkali are strong. Now, let's look at acid salt. How is acid salt formed? Remember, I taught you something. Even the name acid salt should tell you how the salt is formed. Acid salt is formed from partial neutralization when all the hydrogen ion of the acid wasn't replaced by the hydroxide ion. And what is going to lead to an inefficient or incomplete replacement of hydrogen ion by the alkali? This occurs as a result of strong acid and weak base. When the acid is very strong and the base or the alkali is a weak one, the alkali is not going to be able to donate enough hydroxide ions, which is going to completely do what? Completely enhance the replacement of the hydrogen ions in the acid to what? Metallic ion, forming salt. Some hydrogen ion will be left in the system, so making the system still acidic because you still have some hydrogen ion that was not replaced left. So an example of acid salt is sodium hydrogen tetrasulfate 6. How do you differentiate acid salts from other salts? Any salt where you see hydrogen inside, calcium hydrogen tetrasulfate 6, calcium hydrogen triacylcarbonate 5, all acids, all salts having hydrogen for center, now acid salt. So this hydrogen wey dey center na to tell you say hydrogen ion still remain for the system. That's why it's what? Acidic. So this is the example. You still have other one like potassium hydrogen tetrasulfate 6. Here I gave you the one of calcium. You still have magnesium hydrogen tetrasulfate 6, and so on and so forth. They are acid salts. Okay. Among the normal salts, you also have potassium chloride. Okay, you have potassium chloride. But another way to also differentiate types of salts is figuring out the constituents of that salt. Which acid reacted with which base to form that salt? Is it a strong acid? Is it a strong base? I already taught you how to know. If you react a strong acid and strong base, you get complete neutralization. That's a normal salt. If you react strong acid and weak base, you are going to get acid salt because some of the hydrogen ion are going to be left in the system unreplaced. That's why you are seeing hydrogen in the what? The chemical formula. Can you see? So we are going to look at basic salts. I know that you must have had a clue about what basic salt should depict, or about what basic salt should look like according to what I've explained to you for acid and normal salts. Okay, you should be able to create this concept of what basic salt is all about. Now we are looking at basic salt. Basic salt contains what? Replaceable hydroxide ion. It's just like when I explain acid salt to you. Now base turn. The base now is a stronger base, but the acid was a weaker acid. The base is stronger, acid is weaker, acid is weak. The acid will not be able to donate replaceable hydrogen ion that is going to facilitate the pairing of, that hydroxide ion accepts proton, accepts hydrogen ion. So when the hydroxide ion is stronger, the base is stronger than the acid. Acid donates all its hydrogen ion, no other ion to what? To pair with the hydroxide ion. As a result of that, you are going to have some hydroxide ions left in the system, forcing the solution to be what? Basic, because of the presence of what? The presence of hydroxide ion. An example of basic salt include any salt that you see hydroxide in it, OH in it. They are basic salts. So I'm giving you the cheat code now to go and cheat Jamb in the examination hall. So that's it. Any of them will get this hydroxide for inside. Hydroxide will get any basic sign for inside. Hydroxide or negatively charged when you ionize it. They are all basic salts. Okay? And how do you also detect it if a salt is basic salt? You can also detect by knowing the constituent of the salt. It is very apparent and obvious that this salt, this lead hydroxide chloride salt here, was formed as a result of the reaction between hydrochloric acid and lead oxide, oxide of lead and hydrochloric acid. Okay? That's how this salt was formed. It is very apparent and obvious that this salt you are seeing here, this lead hydroxide chloride salt, it's formed from a reaction between hydrochloric acid and lead hydroxide as a base. So this lead salt here is one of the salt that the acid was a strong acid, but something else happened. Okay, and I will tell you what happened. If the moles of the acid and the base are not equal, okay, it can also affect the outcome of the neutralization. For example, if you bring a strong acid and a strong base, we all expect it to yield what? A normal salt, right? Because they are strong and strong. But that same reaction can also yield, but those two compounds can also yield an acidic salt or basic salt. I will tell you why. If the moles are not equal, maybe if acid is higher than the strong base, okay, you are going to have more acid in the system. You are going to have more hydrogen ion in the system. That's making the system acidic. So you are definitely going to have an acidic salt. Okay, you are definitely going to get an acidic salt. But when the mole of the base is higher than that of the acid, you are likely going to get what? A basic solution. So a basic salt is likely going to be formed. So that's what occurred here. Because the reaction is between hydrochloric acid, which is a strong acid, and lead hydroxide, which is also a strong base. And what happened in turn? A basic salt was formed. And why was a basic salt formed? It was formed because the moles were not equal. The mole of the lead hydroxide, the base, the lead hydroxide base, was more than that of the what? Hydrochloric acid. That's that for that. Let's move over to what? Double salt. And double salt contains two different cations. When you say cation, we all know, I already taught you what cations are. Okay? Cations are positively charged ion. That's cation. Anions are negatively charged ion. Anion, negative. Cation, positive. Always use cat to remember it. Cat, positive is positive. Cat is positive, is alive. Cat is alive, is positive. There is life in it, positive. Then anion, negative. So when you say two different cations, okay, you have more than one metal in that salt. That's what it means. Okay, so that's why it's double. Always use that to remember it. Double salt, double. So example of such a salt is what? Aluminium salt. Aluminium salt. And how is a double salt formed? A double salt is formed from an alkali that has what? Two cations in it. There are alkalis that have potassium and aluminium hydroxide. Have you not seen such an alkali? Aluminium potassium hydroxide. It forms as a result of a chemical process whereby an acid combines with a base or an alkali with double cations. Okay, double different cations. That's especially with two metals in it. Okay, just like the example I gave you. And alum is an example of it. Just pick up your phone, search alum on Google, alum chemical formula. You are going to see the two metals that you have in alum. Okay, alum. That alum you are using at home. The compound of aluminium. Before we look at the diagram of neutralization reaction, put it at the apex of your mind that we also have complex salt. And Jamb loves certain questions from complex salt. So complex salt is a salt that has colorful ions. That's number one. And number two, complex salt contains more than 3 elements in it. Complex salt contains more than 3 elements in it. And it's, you see these double salts that you are seeing. Complex salt is a salt that has complex ions in it. You are going to see 3 different metals in one salt. You are going to see zinc, you are going to see lead, you are going to see iron in one salt. That's what complex salt. And these complex salts is always easy to identify their chemical formulas because when you see them, I said you are going to see up to 3 metals in the salt. You are going to see zinc, for example, you are going to see aluminum, you are going to see iron. Such a salt is known as complex salt. They contain complex ion. So complex salt is formed when more than 2 metals react with an acid to form complex salt. That's how complex salt is formed. Okay, and most of the time, most complex salts are not formed from neutralization reaction. Most complex salts are formed when acid reacts with metal. Okay, now let's look at the diagram of neutralization reaction. Salt formation, that's neutralization reaction, whereby acid reacts with base to form salt and water only. And the in-turn solution, the pH of the in-turn solution, that's the extent of acidity or basicity of the in-turn solution, is determined by the strength of the acid and the strength of the base. It is also determined by the mole of the acid and the mole of the base. So when you have equal mole, that's when you will look at the strength. Is it a strong acid and a weak base? Is it a strong acid and strong base? Is it a weak acid and strong base? That's when. But when the moles are unequal, you are going to consider the moles too, not just considering if it's a strong acid or a strong base, or considering strength of acid or base. Okay, so you have to put both into consideration. Now the formation of salt, you see, where acid reacts with base to form salt and water only. So this is hydrochloric acid, a strong acid reacting with what? Caustic soda or sodium hydroxide, and alkali, forming what? Salt. This is a normal salt. Both of them, strong acid and strong base, okay, react to form what? Normal salt, sodium chloride, and water. Only these two things now will form salt and water. If any salt forms apart from salt and water during this process, you know that is not a neutralization reaction anymore. There's also a reaction whereby you react acid with triazocarbonate 4 to form water, salt, and carbon 4 oxide. That one is not neutralization reaction because carbon 4 oxide was still formed, okay? But acid can be formed like that. A reaction between triazocarbonate 4 and acid, to form salt, water, and carbon 4 oxide. Carbon 4 oxide is released as a byproduct. Now, let's look at the uses of salt. Salt is used in food seasoning. Yes, you put that inside food now. Food where they don't put salt, it goes sweet. It's used in preservation. The method of preservation called salting. You know that salt is very strong and is used in, preservation and purification of substance. Okay, you can use it to preserve food. When you salt the food, salt has a very high osmolarity. Okay, it forces cell to lose water. Okay, it forces cell to lose water and shrink. So when those microorganisms that usually destroys food, okay, comes in contact with the salt, they die off due to cell shrinkage. Okay, their cell shrink until they die. They die as a result of what? Exocytosis. Water leaves the cell until the cell shrink and dies. So this is the principle at which salt is used as a good preservative agent. So when you bring the food substance that you use salt to preserve, there's no need to start putting salt in your food again. That food stuff, for example, fish, is already the source of salt to the food. So you just put it, salt's already there. So that makes salt not come over. That's why when you eat catfish is most of the time it's always salty. So they include salt with their preservation method. They also use salting amongst their enormous preservation method used. Now, salt is also used as disinfection. Like I said before, I told you how salt kills microorganisms. Okay, they die from exocytosis. Water leaves their cell, they shrink, the cell continue to shrink until the organism dies. Because of the high osmolarity of salt, especially when it's concentrated. So because the salt is highly concentrated, it forces the cell of this microorganism to lose water to the surrounding.